Good morning, everyone. I hope you're all well, and thank you again for joining this week's webinar, which is part of our ongoing PLM modernization series. If any of you have missed any of the previous episodes, then they are all available on demand, so you can head over to our website and watch them at your leisure. I think this is the fourth one in the series, if I'm not mistaken. So yeah, there are 3 others ready to be watched as and when you want to. Today, then, we're going to take a look at the world of configuration management within Windchill. So let's have a little look at the agenda before we get started. So I'll do a little bit of an overview again of PDS Vision and us as a business. We'll then get into the weeds about configuration management. We'll talk about some challenges and some benefits surrounding configuration management within the industry. And then I'll dive into the capabilities within Windchill that are sort of specific for configuration management. And then throughout we have some demonstrations as well that I'll jump into, showing off some of the features. And always at the end we'll have some time for Q&A, so do please leverage the questions functionality within GoToWebinar, and I will do my best to answer those. If not, I will take them offline and get some of my colleagues to help out. A little bit about myself, for those that you don't know. I'm Rory. I'm a customer success manager here at PDS Vision, and I've been here for just over a decade now, and come from a tech background. So I've worked with CAD, Creo, or the augmented reality products, PLM, and some IoT as well. So a fairly broad knowledge set on the majority of the PTC products that we offer here at PDS Vision. For those that maybe aren't aware, but PDS Vision, we're a global business and we span 16 different locations across the globe. We've got over 500 employees, with over 300 of those being technical experts. So our expertise encompasses the entire PTC portfolio, along with the ANSYS technology, and alongside that, we also have our own range of MyPDS applications, which tag on and add value to the PTC portfolio. So they tag onto PLM, ALM, and the augmented reality products as well, and so do CAD, things like that. So that's a little bit about PDS Vision. I don't want to spend too long on these. But let's have a quick refresher then. And this whole series sort of fits in with a wider digital thread. And the digital thread then, for those of you maybe aren't so up to speed with it, in our perspective anyway, the digital thread is sort of this seamless flow of data that you can picture through an entire product life cycle. Okay, so that data connects people, processes, and systems right from the initial design through manufacturing and service and beyond. Okay, and it ensures that everyone from engineering to the shop floor to out in the field, they make sure they have access to the right data at the right time. Okay, and that enables better collaboration within businesses, faster decision making, and overall a more efficient product lifecycle. So within that, then we're focusing on PLM for this series, and hopefully, if you've been with us on the previous episodes, you're starting to begin and understand why we're focusing on PLM. PLM is really the sort of backbone that enables this wider digital thread and helps divvy out the information to the users that are involved within that product lifecycle. So let's have a talk about configuration management then, and that's why we're all here. So let's have a look and see what Windchill does for us when we're talking about configuration management. So first of all then, configuration management controls product structures, bill of materials, design variations, and changes to processes, keeping all teams aligned with the latest, most accurate data, and ensures products are built and tracked correctly throughout their life cycle. So within business, from our day-to-day interactions with our customers, we always seem to come up with similar challenges. You know, we're all in the engineering space and we all come across similar challenges, but variations of. So things like, you know, incorrect product information. You know, if teams don't have access to the latest and correct data, they may end up making decisions based upon old designs or old specifications, which leads to errors, rework, and ultimately a bottom line cost. You can have different versions of the same product. If you've got multiple teams that work on different versions of the same product, without proper coordination, you can have inconsistencies that arise and make integration difficult. And you could end up with poor communication. You could end up with situations where critical updates, design changes, or supplier modifications might not be shared properly, leading to misunderstandings within the business. We might have wasted time and effort. So without clear organization, teams may spend unnecessary time searching for information, redoing work, or preventing issues that could have otherwise been fixable from the get-go. So all in all of this slows progress. It creates confusion within a business, increases the risk of mistakes, and ultimately could lead to a lower quality product going out to our end customers, which is something we all want to try and avoid. So without proper configuration management, you could think of it a bit like trying to put together a puzzle, but without the picture sort of giving you a clue of how all of those pieces go together. It can be it can be really challenging. So if we talk about some of the benefits then, so configuration management ensures that product data remains organized, and remains accurate and accessible, and it helps teams work smarter, and reduces costs within the business if done correctly. So we could have better design rules where we can save time and reduce complexity by reusing existing designs that are already within the business, leading to faster development cycles. We can improve governance and traceability. We are able to then manage similar products with a unified system, ensuring better quality control and better compliance. We can generate quotes quicker, right? Being able to quickly calculate manufacturing costs can help close deals faster. Increase accuracy when it comes to ordering. Integrated systems prevent errors by ensuring customers receive exactly what they ordered. By leveraging existing data to meet new requirements, we can reduce work, optimize resources, therefore improving engineering efficiency overall. And then hopefully, with the accumulation of all of that, customer satisfaction goes up. If we can reduce the errors, we can improve our quality, generate pricing quicker. All in all, that should ultimately leave your customers in a better place than where they were. So by implementing strong configuration management in your business, we can streamline those operations, improve that collaboration, and ultimately deliver these better products to our end users. Configuration management then really breaks down into two categories. We have change management and we have product structure management. Now, today I'm going to focus mainly on product structure management, as our next webinar is dedicated specifically to change. So I don't want to go into too much detail there on that side, as we're going to have a look at that in a lot more detail next in a fortnight. So let's have a look at product structure management then. So product structure management, it can be a little bit more complex than change management, mainly because it encompasses multiple facets of the business, and catering to those individual business needs or departmental needs. And some things that comprise of this are changes to the structure over time. Our products continuously evolve through design iterations, material updates, engineering changes, and capturing these changes effectively will enable better tracking of historical data. It enables us to compare different versions across that timeline of that product, and we can analyze the product history at any given point in time. We then have different structures across departments. So different departments interact with the product data in different ways, right? Requiring a tailored view of that structure, that same product structure, that is unique for that department. So engineering will focus on the design intent, maybe the technical validation side of things, whereas manufacturing requires maybe an optimized structure for assembly sequences, or product efficiency. And then you may have service and support that needs a breakdown of all serviceable components within a product. So we're leveraging that same data, but it needs to be presented in a way that's suitable for those different departments. And then finally, we've got many industries that offer configurable products, that allow customers to tailor elements of the product to their needs. Managing those configurations requires a structured approach and is commonly classified into sort of different methodologies, things like engineer to order, configure to order, make to stock, these sorts of approaches. So effectively managing these variations requires a robust tool to ensure everything is accurate, it's traceable, and we can seamlessly transition between these different departments within a business. So this is sort of the area we're going to focus on for today. And within that, then within the configuration management, we have these sort of key capabilities within Windchill. We've got BOM management and product structures, which is something we've been talking about. We've got what we call BOM transformation. So when we're transitioning from one structure to a different structure, like manufacturing or service, we're going to talk a little bit about that. We then have effectivity, which is when we're talking about at what point do we bring new designs or new iterations of a product or part into the business. If we've got items already in stock, we want to make sure we're using those up maybe before we bring a new object into the business, or production, I should say. We then have baseline management for creating snapshots, which we'll go into, and then smart platforms, options and variants for these more configurable products, which we'll take a look at. So let's jump into some of the capabilities. We'll start with this one here. So the foundation of PLM defines how products are structured, linking parts, CAD data, and documents. Okay, this is something I have echoed throughout this series and goes right back to that first episode where we talked about the part. So an accurate. Get my words right. We talk about what part an accurate engineering bill of materials plays within the PLM tool. So I'm not going to jump into detail on this. This is something we've been talking about throughout this series. So hopefully you're all starting to get a decent grasp on the role that a well-defined product structure plays within the world of PLM and the wider business. So BOM transformation is a topic that I personally feel needs its own presentation to get into the weeds on. It's a really interesting topic. So for that reason, I'm sort of going to go over a high level overview of BOM transformation, get you an understanding of what it is, how it's used within Windchill, and then gauge some interest in a second about a separate session dedicated to BOM transformation. But let's get into some of the detail. So a BOM transformation enables a seamless conversion from an engineering BOM to an M-BOM or any other downstream derivative BOM, okay, like a service BOM, sales BOM, whatever that may be. So while maintaining critical links between these varying product structures. So we still see that many companies rely on a CAD-centric bill of materials, or they manage multiple BOMs manually across departments using something like Excel or another similar tool. Okay, and with that approach, it can be time consuming and prone to errors. You're bringing in a manual operation, and with any manual operation, you're introducing the risk of bringing in human errors. So let's have a look at the engineering BOM. So hopefully we're all pretty comfortable with the engineering bill of materials, and we understand the benefits of having a fully defined and accurate engineering bill of materials. But once we've fully defined this EBOM, we can then start to generate or derive downstream bill of materials, such as manufacturing, service BOMs, or sales BOMs. So here we can take our engineering BOM and transform it into a derived structure. Okay, in this example, we're transforming it into a manufacturing bill of materials. So Windchill allows us to transform and compare these different structures, all while maintaining associativity. This is key as it enables us to see where components are used and what impact it might have if we wanted to make a change. So I think it's really important to say when we're generating these downstream bill of materials, this is a transformation of this data here in the engineering BOM. Okay, it's not a duplication, it's not a copy. There is an associativity between these items. Once we have our manufacturing bill of materials in this example, and it's accurate, we can then use that and leverage that for further downstream activities. So in this example, I'm showing how we could take something from the manufacturing BOM and enables us to generate a process plan, or routing as it's sometimes called in ERP. And this process plan might involve or include different resources, which manufacturing plants you might have. Maybe you've got a facility up in Leeds that has the capability of doing some form of manufacturing, where you've got another plant down on the south coast that doesn't have that capability. So you can start divvying up work, different lines, the tooling, different work centers or skill sets that are required to carry out a given operation. We've also got access to that engineering data in the EBOM still, so we can take those visualizations and start to create immersive work instructions that are interactive, that can be used on the shop floor. So as people are following and carrying out these process plans, we still have access to all of that information that is stored within the Windchill system. And again, I just want to highlight that associativity. So all of this information is connected. So if there is a change within the business, in this example, we're going to make a change to the clutch, you can very easily perform an impact analysis within Windchill and find out all of the end items or all of the downstream processes that are going to be affected by making that change. And being able to perform that accurately and quickly, you get a very clear picture of what the impact for the business is going to be. So BOM transformation, okay, we can help prevent the loss of data and prevent errors when moving from design into production. We can ensure that all teams are working with up-to-date product configurations. And some of the key benefits, we can eliminate that manual work. If you're duplicating your bill of materials in Excel and reworking it outside of a unified system, that can introduce errors. So doing it in something like Windchill can help with that. We can speed up the manufacturing readiness and improve service documentation. Okay, we can leverage all of this historical data that is stored within the system. As I think I've mentioned before, engineering departments are very good at generating this sort of data that has so many uses across the business if it's managed in the correct way. So just to make sure we're all still awake and there, if you're interested in seeing any more on BOM transformation or would like a dedicated session on it, feel free to send a like or react in some way, shape or form, and we should be able to register that. And if it's something of interest, we can take a deeper dive into BOM transformation. Okay. So baseline management, one of the first capabilities then within Windchill that we can leverage to help understand our data and organize it. So baselines capture static snapshots of product data at key milestones. They're very straightforward, very easy to use, but provide quite powerful benefits when we start looking back at our data and we want traceability. Maybe we're conforming to some regulations and those sorts of things. But as an example, then we can take a baseline or a snapshot of your product structure at a given point in time. So let's say in January we have an initial release of a product. So we can use a baseline to capture this first formal release of this product and establish a starting point for any future iterations of this product. Then maybe in March we have maybe things have moved on slightly, but we then start in March a focused effort on maybe some development. So we've got a sprint coming up. We're going to focus on some changes, and we can generate a baseline to mark the start point of this development process. Then in October, maybe we finished our development sprint, and we generate another baseline to lock in the product state after that development process. By leveraging these baselines, we have these historical checkpoints that we can go back and review. So maybe at the end of our development sprint, we want to go back and review and compare our product structure against what it was when we started that sprint. So yeah, for development processes, key releases, we can generate these baselines that enable us to go back and view our product structures at a given point in time. So as I said, provides a reference point for audits, reviews, releases, and historical tracking. And it ensures traceability of product changes. We can help manage regulatory and compliance. We will deal with a lot of industries that have a lot of compliance and regulations, and being able to leverage baselines can really help with those. And we can support project tracking and milestones throughout a project. Moving on from baselines, then we enter the world of effectivity. So effectivity is the planned date, lot, or serial number at which old versions of an object are replaced with new versions in production. Okay. So it's used to determine when a specific part revision or part revision is planned for use in production. This capability enables the definition and management of configurations and associated feature or rule effectivity. Okay. So by extension, this capability enables the definition and communication of part effectivity to other enterprise systems that require it, such as downstream ones like ERP, and ensures all stakeholders are aligned and the timing of critical changes is updated correctly. So there are several different types of effectivity of how we can determine when a part should be used within production within the business. I just wanted to highlight some of those. We don't have time to go through all of them, but I'm going to go through a couple. But they all work in a very similar way. So we've got date, okay, and that controls when a part or assembly is valid within the business on a specific date, as you would assume. So this is used quite a lot in automotive and consumer goods. We then might have a serial number, okay, maybe that's generated by the ERP tool, but we can track effectivity at an individual unit level, leveraging serial numbers. Again, that might be used in something like the medical industry. We've got manufacturing serial numbers, so MSN, that's what manufacturing serial number. And that's a unique code a manufacturer assigns to a specific product during production. Okay, so we could track it at that level. We also have lot numbers to track a batch or production lot level. And then block, which is a group of serial numbers or a group of manufacturing serial numbers that we can lock together. So this is used quite a lot in aerospace and defense. Maybe if Lockheed Martin produce a new F-55 and they've got block 1, block 2, and block 3 configurations, each block will have its own unique set of updates or variations, which combine a group of serial numbers. So there are several different ways of managing effectivity. I'm going to show you an example of a couple of these in a second. But why do they matter? So we can prevent outdated components from entering production. Okay, it can help with compliance and traceability. It can also help manage stock levels, right? If you've got a new part that has been developed within the business, you don't maybe necessarily want to start using it straight away. You want to wait until some of the old stock, if it's still valid, has been used up. So with effectivity, we can help manage when parts are being used within the business. So again, some of the benefits here, we can ensure a smooth product transition of those components. As I mentioned, we can reduce the inventory issues and improve synchronization. So let's take a little look at some of these then. So we'll start off here with effectivity, and we're looking at date effectivity within Windchill here. So I've got a product here. It's the motor that you saw in one of the previous demonstrations. Take a look at the end item here. Have a look at this product structure by default. So at the moment, we're looking at the default structure, which is just showing us the latest and greatest of everything. So we've got a few things in change, a few things in design, and you can note some of the different versions of those individual parts. If I now open up one of the rotor subassembly here, we can have a look at the effectivity of this component. So this is some information that's historically been set. And we can see that this part at this revision has an effectivity date. And if we cycle back through some of the previous versions, they also have an effectivity range based upon a date. Some of these dates are quite close together. For this demonstration, I was a bit constrained by time. So historically, out in the real world, these time frames would be much wider than they are in this example, but you just have to bear with us on that one. So going back through, you can see that effectivity has been set within these components. So what we can do is, rather than looking at the latest version of this BOM, we can actually go back and filter that. But before that, I just want to show you how we generate that effectivity. So I'm going to revise a component. This bearing here, maybe we've changed supplier or whatever, it doesn't really matter what we're going to do, but we've revised this component, and what I'm going to do is I'm now going to specify at what point in the business this part is going to be used. So moving into effectivity, we can specify a date. I'm going to choose some point in the future, and I'm going to say it's going to be effective until I otherwise specify. So I'm not going to set an end date for this, but you can do. And that I'm now going to set the state back to release, but again, this could be incorporated into a change process. This is something we'll cover in the next episode. So for this example, I'm just going to do a set state and set that as released. If we now go back to our motors product structure, what we can now do is leverage those filters, and I have some historically saved ones here, to view our part structure at any given point in time. So taking a look here at the 5th of March, we can see that our structure has updated, and it's now only showing components that were effective in the business at that point in time. If we swap back to the 1st of March, again, you'll see some of the versions update. Now, obviously, the product structure could change in other ways. In this example, I'm only really showing version changes, but we could have had new components being introduced and those sorts of things. Up top, you can see me changing the filter. And if we push forward in time, we can now see that our bearing that we revised is now in play within the business. So leveraging these filters, we can go in and understand and determine how the product looked at that given point in time. Something we can also do on top of that is compare these structures. So comparing the 1st of March here to the 5th of March, we can use the compared part structure tool to understand the differences in these products. And just cycling through the different products, the different part versions there. Again, your BOM could change in other ways. In this example, where we've only really got some version changes. But finally, then, let's review and compare against a baseline. So rather than the 1st of March, I'm going to change this to a baseline that was taken upon initial release of this product. So I'm now comparing a baseline of initial release to the product structure at the 5th of March, or you could compare multiple different baselines as well, as we talked about earlier. Again, just flicking through some of the changes here. Okay, let's quickly have a look then at serial. So we're just doing a couple of these, serial and date. They all work in pretty much the same way, apart from the actual function of how they're being controlled. So again, different structure here. We're going to have a look at a fan assembly, and for this example, where you are leveraging a serial number based effectivity. So if we take a look at a part in here, just like before, we can see the different versions of this component and the serial number at which point in time they were effective within the business. So again, this serial number could come into play from ERP and maybe is representative of the top level or end item component. So if we take a look at the structure, again, just like before, I have some filters that have been saved that we can use to look at our structure based upon a given serial number. So up top, you can see the filters there that I'm just making a change. I can enter in a serial number, and the product structure is going to update in accordance with that serial number. And again, for those individual parts, you can see the range at which that component was effective. So if we just cycle through a couple of these, you can see how the parts update. So the method of effectivity doesn't really matter. It's just either option you choose, whether it's date, batch, lot, serial number, they all control how your components are being and when your components are being used within the business. And again, finally, we can do another comparison to show changes between two different structures. Yeah, so serial numbers could be quite handy. You know, if you're handing out products and you get one back on a return, maybe your service department needs to go back and understand what parts were used within that original shipment. They can enter in the serial number and find out exactly what components were used when that product was initially sent out, as an example. Okay, and so let's have a look at configurable products then. So this is a bit of I'm just going to jump straight into a demo for this one. So we're talking about products that have multiple different options and variants. Yeah, so you open up your product to your customer base, and they can tailor their product to meet their needs. You know, classic case, you know, a big, I know, Volvo truck is a classic example from PTC. You can have multiple different engine types, cab types, wheels, wheelbases, you know, and all of these configurations can really start to mount up, and you can end with, you know, 10 to the power of X number of possible configurations of any given product. So having a tool to help manage and understand that is a really powerful capability. And so this is something we're going to show off now. So for this example, I'm going to leverage the snowmobile in this data set here. And I'm going to open up a configuration here, well, a product structure. And so if you look at this left-hand side, you can see that we've got an overloaded bill of materials. Okay. So this product structure is organized into systems. Those systems are organized into modules, which in turn define a logical structure. So if I was to expand out the bill of materials, we can see that this product structure does, in fact, you know, contain those systems and those modules and variants. And I say it's an overloaded bill of materials in this sense. So this represents the different options and choices that are available to the user when they're configuring this product. And we can use rules to regulate those choices when the user carries out the configuration. So as well as an overloaded BOM, you can also see that the visualization is overloaded. And just like before, when we've seen these structures, the BOM and visualization work together. That way, the user can get a graphical understanding of all of the available choices for a given module. In this case, it's the windscreen. So this is what the overloaded product looks like. We can now have a look at the configured one, or a configured one. So using filters again, we can access all of the configurations that have been created and saved for this product. And in this case, we're having a look at the 600 Indy here. So you can see we no longer have an overloaded visualization or an overloaded BOM, and it is specific to the 600 Indy. So as the user has gone in and defined the configuration, they will have had to adhere to these rules that were set out to ensure that this is a manufacturable product, and users are unable to put incompatible components together. Taking a look at the hood configuration for this product, we can see that the structure begins to look a bit more familiar. We can see that there's a set of WT parts that have been used for this configuration. And these are the same parts that may be used on any other given configured product, unconfigured product, or another product that you might have across Windchill. Okay. So if we open up the center console on this snowmobile here, this serves as a really good example of a part that could be used across different products, not just these configured ones we're looking at. So this could be the same console that is used on the dirt bikes as well as the ATVs, and users can easily see where this item is being used all from that one Where Used tab. If we expand out the console, we can see how Windchill's part-centric focus enables us to see a fully defined digital product. We can see all the information describing it. It's available to us. We have our mechanical designs. You can see electrical designs in there. We may have schematics, hardware from different suppliers, as well as the software that makes this object function. All that information is captured in this part-centric BOM and is carried with that part wherever it may be used. That way, again, whenever a change is made, we have complete understanding of what impact that change is going to have within the system. So there's one other area I want to have a look at in this model. So let's check the video. I feel like it may have stopped. There we go. I think this paused. Let me a bit behind. Let's just skip through here. Let this catch up. So there's in the main product structure again, there is another component that we're going to have a look at, which is the sub-assembly of the skis on the front. So along with configurations, Windchill also has the requirement to capture replacement parts. And with replacement parts, we're able to identify them as alternate or substitute parts, and these can be interchanged wherever they are needed. Those changes can be applied globally or to a specific product. So now we've seen where variants are viewed, we can now look at how we might get there. So all possible options for the product are stored in the option pool and work together with what we call option sets. Leveraging these tools, Windchill is able to store all possible configurations for this product. So similar to the BOM, we have an overloaded set of options that can be narrowed down for a given configuration. Okay, we have what's called a compatibility matrix that helps visually define those rules and governs which choices are valid and which choices aren't valid. So looking at the CleanFire 600 engine from the engine option pool, we can easily see where this specific configuration is used across various different product lines and option sets on the right-hand side. So that's how we sort of constrain and define our configurations. We can now have a look at how someone goes in and builds a configuration. So again, using the edit filter tool, users are provided with a set of options. If we provide the user with a set of options, taking into account any previous choices. So again, we have that logic built in. An example might be that if the user selects maybe this a storage option for the snowmobile, maybe because of that, we then can't have a passenger seat on the snowmobile. So there's logic within these rules that users go through and choose. So once the user has gone through and chosen those options, the structure and the visualization will update to reflect those. And once that configuration has been generated, that configuration can then be saved for and reused or allow others to view that same configuration within the system. Finally, then, Windchill enables, again, we can compare these different configurations. So in this example, we're comparing the 600 Indy and the 800 switchback. Like before, it's a very familiar user interface. We can see in the top section, we have the part structure comparison. And down in the bottom, we have the visual comparison where we can see the visualizations of these products. And if I just flick through again through some of the changes, we can see what is different between these two configurations. Finally then, once we've generated configuration, Windchill then has the capability of generating a report for the given set of choices. And this final bill of materials can then be used downstream, right? So we could maybe pass this off down to ERP to go ahead and complete that customer order. Okay. So that gives us a bit of an overview. Obviously, we don't have time to go into the details and everything in these webinars, but that should hopefully give you an understanding of how configuration management and what is involved with configuration management when we're talking about PLM and Windchill in this instance. So our next session then is going to be on change management. So we sort of skimmed over some aspects of it today, but we're going to take a deeper dive on change management. So join us for that on the 26th. And then following that, we have our last episode in the series, which is collaboration and working together within a PLM tool. But I will take a moment to have a look and see if we have any questions. I don't have anything just yet, but I will give it a minute to come through. In the meantime, though, I will say thank you all for joining. I hope you found the information we ran through today useful, and I hope to see you again on the next episode. But I will stick around for a few minutes just to see if any questions come through. But thank you very much. I hope you all have a great day.